Welcome to video 5 on homework 4. We're going to take a look at 23, 24, and 25. So let's get started. Now I see this, a limit to be evaluated. First thing I try is direct substitution. Instead of writing it out, let's do it in our heads. 2 times 2 is 4. 2 times 5 is 10. 4 minus 10 is negative 6. Negative 6 plus 6 is 0. 2 minus 2 is 0. So if I were to do direct substitution, I would get 0 over 0, which is indeterminate form. That means I need to try an algebraic method. I can either factor or rationalize. There's no square root, so rationalize wouldn't make any sense. There's an x squared, so I can factor. So let's try factoring. I need two numbers that add up to negative 5 and multiply to 6. So that'll be x minus 2 and x minus 3 over x minus 2. The x minus 2 will cancel. I can put a 1 in the denominator, but I don't really need that because dividing by 1 doesn't change the value of my expression. So I just have x minus 3. In this case, we wanted x to equal 2, so I have 2 minus 3 equals negative 1 is my solution. So first I factored, then I canceled, then I evaluated. Let's try number 24. So if I were to try direct substitution, I would have 1 minus 1 equals 0, and 1 minus 1 equals 0. 0 over 0 would be indeterminate form, so direct substitution does not work here. I can either try factoring, but there's no x squared, or I can try rationalizing, which makes sense because there's a square root. So to get rid of the square root, I have to multiply by another square root. The terms themselves stay the same, only the operation in the middle changes. Now on the top, I just have this mess here I can't do much with. But on the bottom, the magic of the conjugate is if I FOIL this out, I'll have the square root of x squared, which cancels down to just x. Positive 1 square roots of x, negative 1 square roots of x, so those two cancel. Negative 1 times positive 1 is negative 1. Put parentheses around it just to see how easy it is to cancel. And I'm left with root x plus 1. Again, I could put a 1 in the denominator if I wanted to, but it doesn't really change the value of my expression, so there's no use having it there. I want x to equal 1, so I have square root 1 plus 1, or 2. So here, direct substitution did not work. It gave me indeterminate form. So I chose to rationalize because there was a square root. I multiplied by the conjugate, canceled, and simplified. Let's try number 5. So if I were to try direct substitution, I would have 2 minus 2 on the top, which is 0, of course. If I were to try direct substitution on the bottom, I would have 4 minus 6 plus 2, which is 0. So 0 over 0, indeterminate form. Direct substitution does not work. So I can either factor or rationalize. So let's take a look. There's no square root, so rationalization doesn't make any sense. But there is an x squared, so factoring makes sense. So I can factor to x minus 2 over x minus 2, x minus 1. The x minus 2's cancel, and I have 1 over x minus 1. In this case, I have to keep the 1 on the top as a placeholder to make sure that what I have, my expression, stays in the denominator. Alright, so now I can substitute in my 2 for x, and I have 1 over 2 minus 1, or 1 over 1, which just equals 1. So in this case, direct substitution gave me indeterminate form, which means it didn't work. So I went ahead and factored, I canceled, and I simplified. Hope this helped. I'll see you later.